In this first example, we are trying to determine whether or not each of the following are triangles based on the given side lengths. Using the triangle inequality theorem, we must determine whether the sum of any two sides is always going to be greater than the third side. So if we take a look at our first possibility, 3 plus 4 is greater than 5. Our second possibility, 3 plus 5, is greater than the third side, 4. And finally, our third possibility, 4 plus 5, is greater than 3. So since the sum of any two sides was always greater than the third side, we would classify this first example as a triangle. We are going to repeat the exact same process with the second triangle. So we're going to take 10 plus 7, and that sum is greater than 12. Our second possibility, 10 plus 12, is greater than the third side of 7. And then finally, 7 plus 12 is greater than the third side of 10. So therefore, we would also classify this second example as a triangle. Now in our third possibility, we are going to do the exact same thing. So 5 plus 11, that is greater than the third side of 5. But then we run into a problem when we try to add 5 plus 5 because we know that sum is not greater than 11. Therefore, we would not classify this third example as a triangle because it does not satisfy the triangle inequality theorem. In example 2, we are also going to use the triangle inequality theorem to find the restrictions on side x. If we are given that two of the sides of the triangle are 7 and 24, then there's a couple things we must consider. 7 plus 24 must be greater than the third side, which is x. So this will give us one of our restrictions. And we know that sum, 7 plus 24, 31, x cannot be greater than 31. Otherwise, it would not satisfy the triangle inequality theorem. Now, the other restriction we must consider is that 7 plus x must be greater than the third side of 24. So therefore, if we solve this, we get x has to be greater than 17. So our restrictions on x must be less than 31, but it must also be greater than 17. So it's between 17 and 31 in order for it to be classified as a triangle. In our third example, we are given angle PQS and RQS are in a ratio of 7 to 8. So I always label my diagram by labeling the first angle as 7x, the second angle as 8x. So anytime you're given a ratio, put an x with it on your diagram. We can assume that angle PQR is a straight angle which has a measure of 180 degrees. So to set up an equation, we're going to add those two angles, set them equal to 180, and then solve it for x. So therefore, 15x has to equal 180, and if we divide by 15, x must be equal to 12. But the question is asking us to find the measure of angle RQS. If we look at our diagram, we've labeled RQS as 8x. So we need to take 8 and multiply it by x, which we found to be 12. And 8 times 12 gives us a final answer of 96 degrees. So now hopefully you have a better idea of the types of examples you will see in this section.